All right, so based on what a nucleus is composed of, we can actually predict which kind of nuclear decay it's going to undergo. And what we want to take a look at is the N to Z ratio, where N is your number of protons. Oh, it's number of neutrons, my bad, neutrons. And Z is your number of protons. So number of neutrons here in this diagram, and then number of protons down on the bottom there. And then the green is the stable areas. And so one question you might want to ask yourself is, why can't we just keep adding more and more neutrons, and then we can keep anything together, since the neutrons is kind of the glue holding it together? And the answer is a little bit more complicated. And basically, we just can't add more and more neutrons, because similar to how electrons occupy orbitals and energy levels, protons and neutrons do the same thing. So when you keep adding more and more neutrons, you're adding them on higher and higher energy levels. And so after a while, the kind of energy you have to put in outweighs the energy you get out, or the stability you can't get out. That's beyond the scope of what we're going to look at. Just wanted to kind of give you a short version of why we can't do that. And so you can tell there's two scenarios. There was when your N to Z ratio is too high, and you have too many neutrons, essentially. So that's going to occur somewhere over here, right? And so when you're over there, basically what you want to undergo is beta decay. Because remember, in beta decay, a neutron turns into a proton and then emits an electron. Right, so we're going to go towards our valley of stability there. And then the other consideration is your N to Z ratio is too low. So that's too many protons. So that's going to be somewhere over here. And if we're that direction, we're going to want to do one of two things. We're either going to do positron emission, so turning a proton into a neutron, or electron capture. Again, same thing. Those are the two things you're going to want to undergo to, again, go back to this kind of blue line of stability. And so generally when things decay, they don't just undergo one nuclear reaction. They undergo a series of nuclear reactions in order to get to something stable. So we won't touch on this too much, but here's just an example. So on this green is the alpha decay, and then red is beta decay, and you can tell it goes all the way from this unstable uranium-238 eventually down to stable lead.